Hello everyone and welcome to this lecture concerning Java. This lecture will be held in English. If you're available somewhere, either on Slack or here in the room, you can ask questions if you have them in Swedish, and I will translate, of course. As I just said, I will be having Slack open during the entire lecture, and I will be looking at it from time to time. So if you have any questions and you're from a distance, then you can pose your questions over there. Other than that, this will be a lecture about more on Java and also on the future of Java and a little bit of history, but we'll get there. It's not exactly, well, it's now 1:15, so we can begin. And first off, we are going to go over to this little view instead. So the topic for today is modern Java, and with modern Java we mean the things that have been added at a later stage, so the things that might not be seen as the fundamentals, the things that were available in the beginning of Java. There has of course been improvements to Java throughout the involvement of the language. However, we've had some milestones, and we'll talk about why we've had these specific milestones and what that had, well, why we've had them and what that has meant for the language of Java. And with the language of Java, we of course talk about the entire environment, so the virtual machine and all that as well. So the entire Java. The agenda for today will be something like this, namely that I will have a short introduction where I will talk about some of the different versions of Java and the history and so on, and then we'll jump into two other things that are mainly seen as differentiators when it comes to modern Java, so to say. So Lambdas, what that is, and also that we use them most often together with streams. These were introduced in Java 8. Also introduced then was this date and time library, which we'll be looking into, and we'll close everything off by looking at what's happened after Java 8, a few more things, and what you should use, could use, and so on. But we will begin with a short history of Java, going very fast because most of you probably know the basic stuff, like Java being introduced in '95, and more importantly perhaps that Sun Microsystems were the inventors and the developers of Java until 2006. Let me just check. Okay, nothing important. And during the time period 2009-2010, Sun Microsystems were bought by, or rather eaten up by, Oracle. So from version 6 to version 7 we have a fairly large leap from 2006 all the way to 2007. During this time we weren't really sure what would be happening with Java, if Oracle would see Java as something that it would put time and effort into, but it has shown that they will actually use, they need Java, so therefore they will use a lot of resources in order to evolve Java from this time period. Version 7, which was the first release of Java from Oracle, didn't contain very many additions, most notably perhaps the new file I/O and support for dynamic languages in the Java virtual machine. meaning that it was easier to have dynamic languages compiled to the virtual machine. However, the real start, as I've said, of what we call modern Java is with Java 8. With Java 8, they introduced a number of new features, really large features. For example, these Lambda expressions, which we'll look more deeply into in just a few slides. So from 2014, we have modern Java, and we will also discuss a little bit about what will happen with Java from that on, because Java 9 was released in 2017, and it took a while, because one of the key features of Java 9 is a new modular concept. And this modular concept wasn't really they hadn't discussed it enough when Java 9 was supposed to at first be introduced and released to the public. So therefore they had to lengthen the time before the release of Java 9, because they really wanted this feature of modules in Java 9. Because at the time they had a development time of approximately 2 years between different releases. So they realized at this time that they couldn't possibly do it like this. They couldn't have just one feature, this one of modules, holding up all the other features, because there are a number of other features and they were ready and done way before Java 9 was actually released. So they thought, well, let's change this, and from Java 9 and on they are going to have a 6-month release period. So every 6 months there will be a new release of Java. So if there is one key feature, like there will be, for example, in Java 12, that's not quite finished, then we just push that to the next release, which will be another 6 months away, and we can release something with Java 12, for example, which at least is I mean, there are a number of new things in Java 12 without this key feature of raw strings in this case. So they will now try to release, or they will release something, the things that are available from now on every 6 months. So Java 10 released in March 2018, Java 11 released in September 2018, and Java 12 is scheduled for March 2019. And that means that Oracle will be able to keep up interest in Java, will be able to push new features on a 6-month basis, and also that they can postpone features that are not ready yet, need some more care and some more development, but not having to wait 2 more years before that can be released. So probably and hopefully we will get more new exciting features faster with Java now than we've had before. And what they've also done is to minimize the technical differences between Oracle's JDK and Open JDK. The idea is that in the long run, the only difference between Oracle JDK and Open JDK is that with Oracle JDK you pay and you get support, whereas the Open JDK will be deprecated 6 months after its release. So that means that there will be no official support, no security updates, nothing officially from Oracle in Open JDK 6 months after that version was released. That means that if you want to use Open JDK and you want to be safe, you need to update it for every new release. Or, and this is also something that has exploded in the last few months, really, when this was announced, there will be a number of companies available that will help and have support for older versions of Java. So there will be support for Java 9 and Java 10 and so on by companies like Red Hat or Adopt Open JDK and so on. There will be some support available for free, and there will be some support that you can pay for and so on. But they will supply patches and so on for these older versions of JDK as well. All of it then being built upon Open JDK. So basically no differences between Oracle's JDK and Open JDK from now on. There are a few things still that need to be ironed out, but I would say that we're actually more or less done, and in the future we will see these working nicely together. So Oracle uses Open JDK very much for development and so on, and one of the biggest contributors to Open JDK is still Oracle and so on. Okay, but we step back again to the features of Java 8, which is this milestone version of Java, and we will present in the coming slides the biggest contribution, namely Lambda expression. And what it does is giving Java, which is already object-oriented and imperative and so on, it will give Java also a functional way of programming. And with this we mean that it will be declarative, meaning that we will state what to do rather than how to do it. Most of the things we've done so far has been telling Java, go through this array and perform this and this and this operation on each of the elements and so on. The idea with functional programming, to be declarative at least, the declarative part is that you say that go through the array, perform this wherever it might be on each element, but you don't say how. You leave that to the JDK to try to find out the best way of doing it, and that could possibly be to split it up and parallelize it, making use of multi-threading and so on. But we don't know. Well, we can tell if it should be in parallel or not, but we don't really care for exactly how it is performed, just that it will be performed. And to do this with collections, which is perhaps one of the major things here, we have these streams, and these streams help us to perform these actions on collections like arrays or array lists and all the other things that you will learn of later in this course when we get to the data structures. All right. So lambdas. As I said, functional programming. We already have procedural, object-oriented, generic programming, you name it, in Java. As we often say that Java is an object-oriented language, and that is true. That's the main objective of Java, to be object-oriented. But it needs to take influences from other paradigms as well, and it has from the imperative or procedural, and it has from generic programming, and it built up a lot of stuff with this. However, functional programming or functional programming languages has for a few years now been very much talked about, and therefore they've added functional programming to Java as well. And you don't have to use it. Object orientation with Java is something you have to use. However, you can do it really poorly if you like, but you have to do something that's object oriented or object oriented-ish at least. But with lambdas and streams and so on, these are just more convenient ways of doing things that we've done previously. But the focus is what we want to do, and the JVM will optimize the expression or whatever it is we want to do so that it works probably better than most of us, I'd say, could do it otherwise. So a lambda expression is basically a block of code with parameters, and that's the function. And we use lambdas to execute this block of code, and we can do that now, or we can do it later, and we can do it again. So we can pass around this and have new parameters and reuse the expression and so on. And lambda expressions can also be converted to something called functional interfaces, which we will talk about a little bit more later. So lambdas are essentially a piece of code that we can pass around. Execution, as I said, can be done later, repeatedly, and it looks something like this. As I said on the previous slide, it has a number of parameters, 1, 2, 3, 4, 5, and so on. And this will point to, and that's the new syntax, it will point to something, and this something is a block of code. And we can make this even easier to look at. So if there are no parameters used, we don't have to have the parentheses on the left. And if we just create one-liners, we don't need to have the curly brackets either. So let's have a few examples. So simple lambda, just returning a string, is the first one. Then we can use just the parentheses and say, well, this one will return the end. We can return a comparison, for example, between two strings using compare. So in this case, string 1, string 2, as we have as the parameters. This will lead to or point to a function, and as you can see, it's a one-liner, so we don't need the curly brackets. And the block of code that we have here is an integer compare, and this integer compare compares the length of string 1 and string 2 and returns it, because integer compare does that. It returns an integer. And as I said, if we have just one parameter, then the parentheses can be left out. So if we have something like value, it just points to a system out print line like this. And what we can see here is that we can condense the code quite a lot compared to what we've done previously. However, it doesn't work. Well, it works, but it doesn't do anything. As I said, it is a piece of code, and it's a piece of code that we can pass around everywhere. However, we need some means of saying, I want to execute this, I want to execute it now, I want to do this and that, and so on. And to do that, we have these functional interfaces. And we can assign our lambda expression to such a functional interface. And this is the only thing as well that we can assign a lambda expression to. We cannot even assign it to an object. And a functional interface is an interface with a single abstract method. So it has just one method. And this one is what we need to implement for this lambda expression to work. So we use that function or method as, let's say, the way of using the function. So the lambda, as I said, the lambda expression supplies the implementation to that specific and only implementation method. And in Java, we have a large number of these predefined functional interfaces. You can create your own functional interface. And what it basically, as it says, it's a functional interface with a single abstract method. So it's by no means impossible to create one yourself. However, for most cases, there's already a bunch of these implemented in Java util function that we can use. So the simplest one is probably runnable, which takes no parameters and it does not return any value. So again, this is a method that we need to implement, and we know exactly how methods are constructed. I mean, if we look at a normal method, it has a return type, and it might have 0, 1 more or more in parameters. In this case, runnable doesn't have any return type, so void basically, and no parameters going into the method. So we can create something like this, a simple lambda expression of the type runnable, which is a functional interface. We call it really, and we assign it the expression, the lambda expression, which doesn't take any parameters in, and it points to a block of code, in this case a system out print line, and that's all it does. So it's I mean, you're not going to get a Nobel Prize for this one, but it shows the basic functionality of the functional interface together with lambda expressions. So now really this object really holds the expression, and this object is something that we can pass around in our application, and when we feel that we are ready, we will execute it, and we execute it by calling the run method on this method, on this object. So when we execute really.run, then, but not before, this system out print line will be executed. And there are, as I said, a bunch of these interfaces, and they have had the same basic structure. So we see runnable, for example, which takes no parameters and have no return types, and the abstract method is run, and run is what that's the abstract method that we give an implementation to, and that's why when we say really.run, that it executes the lambda expression. And we see that we have a number more. Supplier T doesn't take anything in, but it does return T, and we have the abstract method get. Consumer, the other way around. Function takes one parameter in and returns another one, and it uses apply for method, abstract method. And then we have by function, predicate, by predicate, and these have test as the method, the last two of them at least, because they return a boolean. So what we need to do is to understand which of the different interfaces we need, and then we supply a lambda expression to that functional interface. And if these are not enough, There are also a bunch more, but if those that are predefined aren't enough, then you can create your own functional interface. And then it's really recommended that you use the @functional interface annotation to help the compiler to really check this. But let's look at a few examples. So we have a by function, and if we go back, we see that by function takes 2 parameters in and returns a third one. And if we look at this one, we say that we will supply 2 strings as in parameters, and the last one, the integer, will be the return value that you get when you run this expression. Okay, and that means that we will have to create a lambda expression that does just that. And we already have this string 1, string 2. Those are 2 strings that are in parameters to this integer compare, which checks which of the 2 incoming strings is the longest. And in this case, we run it by using the object comp, which is what we've just declared, .apply, supplying 2 different strings, Anakin Skywalker and Darth Vader. And the result of this comparison will be put into res, which is a normal integer. We see that, or rather it is an int, so it's a primitive type, and we have to use the class types when we define our functions. So it says integer over there, but it will be automatically converted to an int. Next one is consumer, and if we go back and look at consumer, we see that it takes an in parameter, but it doesn't return anything. So consumer string, in this case, we call it value output, and what it does is it takes this value and it passes it to a system out print line, basically. So it just prints it out. And to use it, we use except, and we do that with the result that we got before. So in this case, we use value output, and we say we want it to run now using the except method, and we put in the string res plus an empty string to create a string. This means that the result that we got from the comparison will be put into the value output object, which will then execute the system out print line. So that's where we get the 1 down there. It prints out the result. And we do the same with supplier. We supply, in this case, a string. We call this output. It doesn't do anything other than returning the string the end. And if we again use value output, because we can reuse this object, but in this case we send another string. In this case we call output.get, which will return the value of output, the end, and in this case it will supply it then to the consumer, which will print it out. And lastly, we have this runnable, which will just print out, no, really, the end when we run really.run, and we get the output that you see there. So creating pieces of code, telling us what kind of data types we want to supply to this piece of code, and then we can take this code and pass it around and do whatever we like with it. And then we just run the method that executes the expression when we want it. And there are a bunch of more things that you can do with this. For example, we have method references. So a new operator, : which makes it possible for us to call a specific method and just push our value, for example, to that method, or creating a new object using colon new, and so on. And we just see an example where we can create this consumer object which prints a value. We've done this so far using value pointing to system out print line and then the value, but it would be possible for us as well to create this as just system out print line with the double colon, as you see down there. So you see this from time to time when we want to call a specific method and just send the value to that. And just to show that you don't only need to have one-liners, here's a rather stupid example which basically just takes the even values and add 1 to that from an array, and it's not in any way the best way of doing it, but we have something that we call runnable change. So the object is change, and as it is a runnable, we don't have any in parameters and we don't return anything, and therefore we just do a bunch of stuff. In this case, a for loop and an if statement, just to show that it can be so much more than just one-liners. And when we run change.run, it will alter the content of this array, and this can be done a lot easier, better, and so on with streams, which is what we're heading for in just a few slides. The idea of lambdas was first because they wanted from Oracle's point of view to have something that helped us in getting a lot of excess code away, making code cleaner and so on, and therefore using it with these abstract or inner classes. And we are later on going to use JavaFX for graphical user interfaces, and there are two ways, the long and the short way, using or not using lambdas to react to button events. And you don't need to understand this now, but I just want to show you how it works, because it shows how much simpler the code will be, and also how much easier to read the code will be. So if we want to create an action for a button, before Java 8 we did something like this. BTN in this case is the button itself, so the button object. We have a method called setOnAction, which gets executed when we press the button, and this one has a new event handler taking an action event, so it's an inner class that gets created when we push the button, and this one needs an implementation, and it has just one method, so it's actually just a single abstract method. And this one is called handle. It takes this action event, and in this case it just prints out hello world. These are the steps that we need to take in order to follow the entire chain of what actually happens by creating a new inner class, or rather the object of it, and then overriding or implementing the single method. With Java 8 we can replace this with, as we know that we are going to have just one in parameter, we can use event or E or whatever. We know we have one parameter in, so we say that, and then this little pointer to the method itself, just printing out system out print line, hello world in this case, because we know that there is only one method that needs to be implemented, namely handle. So therefore implicitly we know that this will be implemented by this lambda expression, and it makes the code so much cleaner, easier to read, and easier to maintain. We will be looking more on this later when we get to JavaFX. But we will now move on to what we call streams, because one of the ideas of using lambdas is to use them on a collection of values. So we have a stream API that was introduced at the same time as lambda expressions. So this will give us this more declarative way of using values in collections. So we just say that we want to sum up whatever is inside, or we want to everything inside should be multiplied by 2, or only the even number should be, and so on. So we say what should be done, not how, and it also makes it a lot easier for the JVM, if we so want, to parallelize this also. We just say that we want this to be done in parallel, and the JVM will attempt to do that. Also, there is this new type called optional, which was introduced during this time period because they wanted something safer than null, and we will see this one used a little bit later. Superficially, streams look like iterators. We have something that we call a stream pipeline, something that begins from a data source, an array or a collection, and we tell it to be a stream, either directly or through a number of methods that are available. This should be a stream, and then we apply a number of intermediate operators like filtering or mapping and so on. We're looking at this. A number of methods that we add to this that in some way transform or changes the contents. So we chain a number of methods for doing this, resulting in the last one being something that gives us a result. It's important though to know that in streams we don't store any values. It will still be stored in whatever structure, collection, array, whatever it is we have. It will still be stored there, but it will be manipulated by the stream. So it's never mutated, always returns a new stream with the results, and these intermediate operators are also sometimes called aggregated operations or stream operations. And they are all defined in stream interface. And it works like this: creates a stream, specify intermediate, and apply a terminal operation. So creating the stream for just saying that this collection should be seen as a stream, and then we have the aggregated operations or stream operations or intermediate operations, whatever you like to call them, that will transform the result, and we can have a number of these. But lastly, we need to have a terminal operation that will give us the final result back. And let's look at a initial example. So we have an array of double numbers this way, and if we want to have the total, so we want to sum everything up, this can be done using a for loop, as we've done previously. So we say that for every double element in numbers, add to a total which begins with 0, and then we add all the different values to this one. And we state exactly how this is going to be performed using the new Java 8 additions. And notice that so far we are not using any lambda expressions, we're just using the stream API as such. But we make this very much more declarative by saying that we use the class arrays, which we use in order to work with arrays, and we say that we want to create a stream out of numbers, and then we apply sum. And that's all that there is to it in this case. So that gives exactly the same result as the top one. We don't need to know how this sum works. We just need to use it. And as always, the idea here is that those engineers that have created the sum method are probably really, really clever, and they've done it in a good way. The first one, the one that we've been using so far, is called an external iteration, and it's more error prone as it leaves everything to the programmer. The other one is called an internal iteration, which means that the library decides what the best way to do it is. And then we have a bunch of examples that we are going to use, and we are going to, in this case, I've used the Bible. It is a fairly substantial piece of work, so that's why I've used it. There are a lot of words in it, and there's also no patent on it anymore, or copyright, I should say. So in this case we want to count all the words longer than 7 in the Bible, and it appears to be about 55,000. And we begin by just reading the content of this text file into a variable, a collection that we call words. And you don't need to understand anything more about how exactly that is done, but basically we're just splitting the contents of this text file into separate words. And this is not a foolproof way of doing it, it's just a quick and dirty way of doing it, because we want all the words to be in the collection called words. And if we want to do this using an external iterator, counting all the words greater than 7, we can do that with a for loop. So for each string W in words, if the length is larger than 7, we add to a counter. Or we can use it with an internal iterator, and now we are using lambdas, because what we do here is that we take these words, which is a variable or the collection, and we say create a stream of this, apply a filter. This filter, well, it's actually not using lambdas just yet, but this filter will it is, of course, because this filter will apply a function, or a lambda expression, I should say, which is this, that for each word create the check if the length is greater than 7. So we have this lambda expression which we pass to filter method, and it will apply this to all the words, and we just want to pick out the words that are longer than 7, and we end it all with a count, which actually counts the number of words that conform to this lambda expression, and we get the same results, about 55,000 words from both of them. And in a way, at least, this last one is a lot more compact to begin with, and it's also fairly easy to follow once you understand how it works. I do admit that it sometimes takes a lot of time to get there, to understand how to do it. However, when you understand it, it's fairly easy to read. And that's what we are going to do in this course, because you are not going to go into all the nitty-gritty details of everything, but you should understand basically how it works. And these intermediate or aggregated or stream operations, well, there are a number of them. For example, filter, which takes a condition, as you saw, distinct, all the unique elements, limit, specific number, map, which applies a function or lambda expression onto if we want each of the elements. So we can take the square out of each element, or we can take only the first letter, or we can take we can make everything lowercase or whatever, so it maps something onto each of the elements. Or we can sort. And we can use a number of these intermediate operations. However, we can just use one terminal operation, which is the one that ends this stream. So we can use for each to go through each of the elements, or we can reduce it to count, returns just one value as we saw previously, or average, or mean, or max. We will see later on collect and to array and so on, which will make it possible for us to get a result which is actually a new collection, but onto one which we've done something. Or we can search, like find first, find any match, and so on. And we can only use one of these as it returns the result of the entire action that we've done. And we're going to go through all of this, but I think it's a good idea to take a 10 minutes break because no one's awake here anymore. So you're all wide awake and really great here. So we take a 10-minute break and then we will continue. Då så. Well, in English again, we are back and we are going to continue working with our lambda expressions here. So, as I said, there are 3 steps in creating these streams. The first one is to create the stream itself, and any collection, array or iterator can be turned into a stream, and the stream class, or rather the stream interface, has a method called off, which helps us to do this. And it's possible to call stream for many collections, which will just create a stream of whatever it is. And there are also a number of methods available which you can use to create an empty stream, or generate a stream, or iterate a stream, and so on. So there's a bunch of things, and I'm going to show you a number of examples of how all of this is done. All of them will of course have all the parts, namely the creation, the intermediate operations, and a terminator, because you need that. However, in these first examples we will concentrate on what's happening on creation. And as we can see here, there are more, of course, on creation itself. We can create using in-stream, long-stream, double-stream, and so on, which are helper classes to help us create these specific and therefore more type safe conversions to streams, or use as a stream, I should say. So if we have int values as we have here, we can create a stream using int stream, and then we say of values, which is this int array, and then that's the creation part, so to say. And then we have an intermediate, which is average, and then we have a get as double, which gives us as a terminator the result back of this average that we've gotten, and we print this out, or we can return it to whatever we like. Probably the most interesting part are the transformations, so the possibility to actually do something on the values that we have in our collection, or rather in the stream, but we work them through. And we've used filter previously, or as in the last example, average. And filter uses a condition which is matched for, which it constructs as a lambda expression, which looks like a predicate, as we saw previously, which is basically what it is. It produces a boolean. It takes one parameter in, and then it returns a boolean. And if we want to change the content, filter will just filter out according to this expression. But if we want to change the content, we use map. We can do something like we see down here. If we have the same array as previously with all the words from the Bible, this first case here creates a stream of words, and onto it maps S. And what should it do with the S? Well, it should take character at position 0. So it takes the first character. And what this example also pinpoints is that if we end here without a terminator, then the return value that we get here is, in this case, a stream of character. And if we want to do something of that, we can call a for each on this first char, for example, and then have a print out lambda expression as done here. But we could equally well have put this for each at the end of the first one and not return a stream character, but just so that you see what's actually returned and created. And it prints out, in this case, the first letter in each word. If we want to change all the words to lowercase and count the numbers of words starting with Q, we use the combination of map and filter. And what we do is that we again take these words, create a stream of it, we apply a map, namely we want to actually change or create a new stream, but we want to do something actively on each of the different elements. We do that with the map. We want to use toLowerCase, which is a method in string. So string :toLowerCase, meaning that send whatever value it is, whatever element it is, to string toLowerCase. And when that's done, we filter out all the words starting with Q by applying this lambda expression S should be pointing to S dot starts with. So these two different transformations work together. First we just make everything lowercase, and then we filter out anything starting with Q. And lastly we have a terminator, in this case count, which will contain then the number of words, which is about 300. So it concatenates several streams into one complete and calculates the end result. And again, by looking at this example, we see that what we are doing is telling Java what we want to be done. We want the content to be lowercase, and we want to filter out anything starting with Q. We don't say how to do that, just that we want to do that. And we have a number of others that you can read through. We can create random numbers like this by calling math random limit to 100. We get a stream containing 100 random numbers. We can do the opposite, namely to skip. So the opposite of limit is to skip a number of them. Real concatenation can be done with concat. This only works if the stream is finite, because if we don't give it a length, it will actually be seen as infinite. Distinct, if we want to get all the unique entries or elements in a stream, we can again use words.stream for creating the stream, and then use distinct, and it will check all the unique elements, and then we have a count, about 13,500 words. And the last piece is of course the result, and we've seen loads of results, but this is also called reduction, and that's because what we do is that we condense everything into a result. We reduce everything into a result, so it terminates here. Count as double, I think we saw somewhere, and a number of these reductions use this optional type, so we can ask the object that we get back is present to see if it was obtained or not. And to get the value if present, we use get, and it's easier to see with a example. And here we have the names of people of a really great, I could say even the best music band in the world. And we see the names: Roger Waters, David Gilmour, Nick Mason, Richard Wright. So what's the name of the greatest rock band in the world with these guys in it? And this stream will not end before you get the correct answer. It should be really easy because it's the greatest band in the world. Well, it's Pink Floyd. Of course it's Pink Floyd. Okay, that will be in the exam as well. The greatest band in the world. And then you need to say Pink Floyd. There were one or two at least knowing it in Slack. Great. But on to the real stuff here. So we have a list again here, names, we have an optional, as you see here, of string, to which we will send this object, or create the object found, which takes the string, filters on, contains David Gilmour, and find first. So find first here will find the first occurrence of the name, or rather string, in this case David Gilmour. And what we can do with this found object, which is really the good thing here, is that we can use it in an if statement. So if found is present, namely that we've gotten a result, it's not empty, it's a lot better than checking for null. So if is present, then we can get the value by using found.get. And as I said, this is a lot more safe than using objects. Oh, sorry, using nulls. But from time to time we also want to collect the results, and we can do that using collect method in a class called collector, and we can set it to a list or to a set or whatever else we want to do. And well, it's easier to see an example really. If we want to find the words in lowercase starting with a Q and return all these as a list, we can do that with this expression. So words, create a stream, add a map which makes everything lowercase, take distinct, so all the distinct unique words, and filter out the words starting with a Q, and then, and this is the new thing, namely that we collect the result using collectors class to a list. And that means that we can return everything, everything back to a list. And this is the list unique words list, or rather unique Q words list. And we're able to print it out using a for loop, or why not using lambda and streams instead, as we do in the last line there, with this internal iterator instead. And then we use the for each. So for each value, print out the value. And we could use this double colon notation for that as well, if we'd like to. I've mentioned from time to time that streams also makes it easier to parallelize, and so far we haven't parallelized, but there is, instead of using the normal stream, it is possible for us to use parallel stream instead, and then the JVM will look at it and it will see how the best way is to create this in parallel, how to make it as fast as possible to do this, whatever it might be, in parallel. And it does it the best possible way based on what it finds in the computer, what the JVM finds is possible to use. So we don't need to know anything more than we want this to be run in parallel if possible. And even if everything needs to be in order in the end and so on, you can partition out all to different threads and so on, and then recombine it later on. So the only thing we need to do is to say that we want this as something done in parallel. Now we've changed book to the Vida instead, which is also a book with loads of text, which is what we want. So we read it. New contents is the name of the collection holding all the different words, and we start a timer using nanotime. We'll look at another way later on, but we use nanotime right now. And we start by counting the number of words using newwords.stream.count, as we did before. and we will get a number of words. I don't remember the number, but we get a number of words, and we see the time by looking at the difference between stop and start time. And then we do the same thing, but we change new words dot stream to dot parallel stream and count instead. And then it will utilize the computer and try to find the best way of parallelizing this. Even though the Veda contains a large number of words, you can see over here that it goes exceedingly fast however we try to do it. But we can also see that there is quite a large difference between these. And I think this was actually first done on my old computer as well, so it was a tad slower than this one. But we can see that there is a considerable difference in speed. And we haven't done anything difficult. We've just added parallel stream instead of just stream. So this is again one of the great advantages that this stream together with Lambdas gives us. And water pause. There's so much more you can do and you can learn about this. Use your favorite search engine. There are numerous tutorials on this. I'd say perhaps the most important thing for you is to have a general understanding of how it works, because when you search Stack Overflow or you Google examples and solutions and so on, sorry, you will by now, as this has been active since 2014, you will from time to time see people giving you suggestions using lambdas and streams and so on. So therefore you need to be aware of them, understand that this is a lambda expression or this is a stream and it's working together with the lambda expression and so on. So you need to understand it, and you will test it out in the first assignment as well. It's really great, it's really neat, so please try to understand as much as possible of it. But by that we will move on to more things that are new and interesting in first off Java 8 and later on in others. Because in Java 8 they finally introduced a new date and time API, because the old one was really bad. It wasn't thread safe. Years in date started at 1900, months start at 1 but weekdays at 0 and so on. There were a bunch of problems in it, really inconsistent. Numerous of third-party libraries, like for example JDK, they have now been superseded by Java 8, and what that has given us during the last few years, a standard way of handling time, which is really robust and has all the things that we need, probably. So in this new API, each day has exactly 86,400 seconds, and a specific point of time is represented by an instant, so the class instant, and it has an epoch or origin at midnight January 1st 1970, calculated from Greenwich Royal Observatorium in London, which is this UTC, so the Universal Time Standard. So it's compatible with the way that we look at time now. Instant goes back 1 billion years and it goes forward 1 million years, basically to the year 1 billion December 31st, and that should be sufficient for most users. You will not be alive when time ends, and I mean that's probably how the Maya Indians were thinking as well with the year 2012. No one will be alive by then, but I think that we're pretty safe with that time scope. We could use, as we did previously, nanotime to get time, but in Java 8 we probably should use this instant instead. So we use instant now to get the exact time right now, and then we can use it again to get an end, and we use duration instead for finding out the time that has elapsed between two different measurements. So we don't need to make an ordinary minus and then do. Things can go wrong if we use the wrong data types and so on, and we can get the milliseconds or the seconds and the nanoseconds and so on. So it's a better way of calculating the exact time. And apart from just having this duration, we have plus and minus, multiply, divided, is 0, is negative, and so on. Also notice that all times are immutable, so they always return something new. We don't change anything, we just return new things. So these are the few other things that are available. However, we also need to have, we cannot just count the seconds from or milliseconds from January 1st, 1970. We need to have something that's more human-like, and there are two kinds of human times that are available in Java 8 and later: local date time and zone time. And this really makes it possible for us to create really intelligent time. Zone time when we need exact time at a specific place, and local time if zone isn't needed. So for example, the launch of Apollo 11, that was done at an exact time and place, and this will require a time zone. So the time wasn't the same in Sweden as it was in the US when this rocket launched. Okay? However, your birthday does not really need that specific time and date and place that exact, because your birthday is a day in a month basically, so we don't need that exact, and therefore we have a lot of classes and methods and so on that helps us to make calculations on this. So let's start with local date. And local date today, and this you'll see later on is a bit off because I did it a few days ago. We get the current date. Today is, print out today, and we can say that tomorrow is +1, next week will be plus weeks, and we give 1, and the day, so the day Monday, Tuesday and so on, we get by get day of week. We can check if this year is a leap year, and we can use period to check how long it is before we can watch Star Wars 9. This is the preliminary date of Star Wars 9, and if it is this December 19th, I will be there looking at it, of course, as should you if you want your grades. We will have a check both in Kalmar and Växjö so that everyone goes to the premiere showing of Star Wars. Everyone except Jonas for some reason. With this period we can get, we know the local date of when we at least think that the film will premiere, and we can use until get years, get months, get days to get a countdown to that specific date. And we see that when we run this, it's pretty soon. And I did this on the 19th, Next week will be the 25th. That means tomorrow, and that's correct since tomorrow is Friday, so tomorrow a week ago should also be a Friday. 2019 isn't a leap year, and I would have been surprised otherwise. And and we use period then to calculate the exact here. Okay. It's also it is fairly intelligent because it will help us not to get to a date that doesn't exist. So if we add 1 month to the last day in January, we will get to the last day in February, not 30 or 31 days off, so February 30 or something like that. So we will get the last day in February, so it helps us with all of that thing. And there's also a class called temporal adjuster to adjust dates. For example, finding the first Tuesday in a month. So we can go back to 2014. We can go to the month of March, and we use with temporal adjuster next or same day of week Tuesday. So it's actually March the 1st, and then we find the date of the first Tuesday in that month. And that's kind of cool. It's not something that you use every day, but it's cool that everything is available there for us. So first day of month, last in month, so on. Create local time. Bedtime is 8 hours after. Wake up time is 8 hours after bedtime, and so on. So it gives us a lot of control over different things that we want to do with time, and it helps us calculate backwards and forwards, and helping us not getting a date which is impossible. And for zone time, we have these internet designed numbers authority time zones, like for example Europe, Stockholm, and so on. There are about 600 of these times, and you've probably seen them from time to time, which actually defines a specific time zone that's used in that piece of the world. And this is something that we need if we want to set a zone time for the launch of Apollo 11. We use zone date time, and then we say 1969, and then months begin with 1, so up to 7, 16, 9. This is more or less the exact time. I've stolen it somewhere. I have no idea. But it takes the time when the Apollo 11 launched. And the important thing is the last part, namely that we also add the zone ID of, in this case, America, New York, so that we know we can then, for example, check what was the time in Sweden or in France or wherever when this happened in the US. And there's loads of more information about that. So more date time formatters for French, Swedish, whatever you like, so that the time and the date is printed in the way that's natural in that region. Clock for using the machine clock. It's also possible to use other calendars like the Thai Buddhist time. At the time of writing, I think the Thai Buddhist time was whatever it says there, 2557:04:04. I don't know exactly what it is right now, but we can get the date in Buddhist date for today's date by executing the lines over there. And then we know exactly what year it is according to the Thai Buddhist calendar instead. And there are a number of these calendars available, making it fairly easy for us to understand and interoperate with other calendars. Here are a few pointers to more information about Java 8 specifically. for example, the documentation, and Core Serverless has a nice tutorial on Java 8. I've used a book called Java SE for the really impatient, which is a short book by this Horstman that you know of. He hasn't included this in his big Java book, so it's not available there. There's some information about it in Liang, but you're better off using the internet for finding information about this. So this was the Java 8 additions to Java, but Java hasn't stopped there. However, it's still the case that those things that we've looked at now, they are the major, the large revolutionary changes. So Lambda expressions and the Stream API are still the largest things that happened, that has a large impact onto Java itself. However, we will go through some of the later versions of Java as well to show what's been happening. So Java 9 was released in 2017, and the largest or major new addition was the new module system. And depending on which order we see these lectures, so this is actually lecture 3, but Jonas will have a lecture 2 after this one, where he will discuss dependencies, for example, and class path and packages and so on. And this has long been a problem in Java. However, with Java 9 there's a new way of doing it, making it easier to exactly say what parts need to be internal or external for this project. That also means that we will produce smaller executables, and it's easy for us to create these executables. One of the reasons I wanted to do this modular Java is that they want us to use Java for IoT devices, for example, and in those there might be the case that you want to minimize the executable because it will run faster and you have precious space and CPU power and so on. So modules as an idea is a really great one because it helps us to say exactly what should be in this project. So reliable configuration, strong encapsulation, scalability, platform integrity, improved performance. That's what's in the JSR, the specification for this feature. So in order for this to work, they also had to modularize the entire JDK, meaning that all the different parts they needed to put them in different modules so that you can say that I want this module, but not that module, and so on. And they have dependencies on themselves, and this means that if we want to create or use another module, we need to say in a module-info.java file that we need this specific module. It's required in this project, and we will see what that looks like in just a while. So parts like base, SQL, XML and so on have been modules, and everything around this modular was the reason why it took so long time to get to Java 9, because all the people involved in creating Java at this time, they weren't really sure how to do this, and there were a few different routes that they could have taken. So that's the reason why they decided later on, well, we cannot have just one feature stopping the development of a Java version anymore. Let's go down to 6 months of development time and then push something out. Okay, so As I said, everything that we need we will put into a file called modules-info.java, and we say that it requires certain things, certain packages, and we also use export to say that if we use this module you will get a number of packages. And we can query Java itself by using java --describe -module and the name of a module, and we can also list all the modules. So if we use that for java.sql, and this is for Java 10, it will say that this module will export java.sql and also javax.sql and javax.transaction.exe, and it requires Java base, it requires Java logging, and it has different levels of how it needs it, like transitive or mandated and so on. So it's ways they can at least define the level of inclusion. And lastly, it says it uses Java SQL driver. So apart from just requiring, it also says that it will really use this driver module as well, and that is a service that it makes use of instead of the packages that are the others. And this exports and requires and uses, that's what we put into a modules-info.java file. And the idea is that we should use it for all projects. It's now possible to say when we create a project that this should be a module project, and then we get this modules-info file directly, and we need to specify all the things in it. In reality, not everyone wants to do this, because it means that we need to keep track of what we're using, how we're using it, and so on. So this means that we can actually use Java just as we did before, and that's a good thing, because it's sometimes a bit of a mess doing this, and it's sometimes not as clear how to do this and so on. So it added an extra layer of complexity, but it also in the long run solves an even greater level of complexity. So that's why we should use it, but you don't need to use it in this course. More can be found on the internet of this. Another key feature which we should use, at least as teachers for you students, and something that you could use just to test things out, is JShell, or as I sometimes pronounce it, JSHell, because I don't like JavaScript. I think that's a good abbreviation. What it is, and you see sometimes I also capitalize the H. It's not by it shouldn't be it shouldn't be capitalized. However, what it is a REPL, a read, evaluate, print loop, and it basically gives us the entire Java language for us to use by simply typing in an interpreter, more or less. That means that we don't need to set up an entire main class. We don't have to include or import, I should say, all different libraries. Most of it is available for us, and we can test out things really, really fast. So everything, almost everything, I should say, can be done. So expression statements, even multi-line expressions or statements. And it's available in most IDEs or from the command line by running JShell, sorry. And if we do that, we get something like this. So if I go to my terminal, I open a terminal window, and as print JShell, it says welcome to JShell. This is for version 10, and it's exactly the same in 11. And then if I print system out print line hello J shell, again with a capital H, not really needed, it will print out hello J shell. And this J shell prompt returns as long as we have this up and running, we can continue printing stuff and testing stuff out. And it works with variables. So if I state something like int numbers 1 and assign it 10, it will say that number 1 is now 10. And if I do it with number 2 with 20, it will say that. And it makes it possible on the third J shell here to make a sum of number 1 and number 2 like this. And it will give us a sum of 30. And I can use it in a system out print line. The sum is plus sum. And there's also rudimentary support for auto-completion. And this is a great tool for trying out stuff. And as I said, we don't need all the excess code that we have just for creating a Java program. We don't need to compile anything. We just print it out and try it out and so on. And it makes life a lot easier. And we can do most of the stuff like classes, if statements, iterations, even getting input. And we don't need to import the scanner class. It's done automatically for us. So if we declare a variable or an object, scanner input new scanner system in, like we've done hundreds of times previously, if we do that in the J shell, we are able to use it. So it returns something really strange that we see there. Delimiters with infinity string, blah 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 blah, and so on. But it is our object. So we can then say that int number 3 should be input.nextInt. So nextInt is what we usually use to get an integer. And then if we press return, it will ask for, in this case, a number. If I put 42 in it, this will now be in, and press return, this will now be in the variable number 3. So a fast, easy way to try this out. And there's a bunch of more stuff that you can do, list and reset everything and so on. And a really ugly editor, if you really like. This is what I've done so far. It's really ugly, but never mind. It's there. It's part of standard Java by now, and it's a really great learning tool. Okay, moving on to the last few ones. Java 10 had 12 new features, better garbage collection and memory optimization and so on. Loads of stuff that's internal to the JVM, but we benefit from it by the language being more robust, faster, better performant and so on. And the most talked about is probably this local variable type inference, meaning that on the left hand side on an expression we can use var for variable, just as in JavaScript, for example, instead of the exact type. But this in Java can only be done if it is possible to infer the type on the right hand side, and it will become that specific type, and that's also important to remember. So it will become a specific type. So if you try it in JavaScript, you can mix and match and do really ugly stuff. However, you cannot do that in Java, because as soon as the variable gets a value, it is set to a specific data type. And this is especially useful when you are working with streams, when you don't always know exactly what it is you get back. But you should not use it just because you're lazy, please. Here I use something called secure random, which gives us random numbers basically, and you should also look up whatever this lambda expression is doing, but I give that as an exercise. The important thing is that in the first line here we declare a variable var number and we assign it the value 10, and we can do that because the 10 on the right side here will be an integer, and we know that. So whenever that is done, this value or this variable is an int and nothing else. So we can do number plus plus. Where it's really convenient is, for example, when we create array lists. So instead of on the left hand side say array list integer list assign new array list integer, that we usually do, we can skip the left hand side and just put var like that. And then we have these random numbers, as I said before, and this the idea here is that var numbers here, as it is the result of a call to random numbers which uses map to object and then collects using something called joining. We are not really sure what the heck is getting back. So we can use this var to get the information back, and then we have a printout by using system out print line in this case. So it's convenient, but it shouldn't be used just because we are lazy. The 11th version of Java from 2018 in September. Many minor or major, depending who you are, things like garbage collecting, flight recording, heap profiling and so on. Added a new HTTP client which supports HTTP 2. String has an additional set of methods which we can use for checking if it's blank. We can repeat, strip and so on. However, Java 11 will not be remembered for the additions, but rather that Java 11 removed a bunch of stuff. So, as you may be aware, Java, or Oracle rather, does not anymore lead the development of what was previously called Java EE or Java Enterprise Edition. It has handed that out to Eclipse and given it it has been renamed Jakarta EE Enterprise Edition and so on, and therefore a number of Java EE libraries are not anymore available in Java from Java 11, and the same goes for a lot of Corba modules. However, no one's using Corba anymore, so that's not a problem. A problem for us is that they decided out of the sudden that JavaFX should no more be part of standard Java. So all the JavaFX things have been put into OpenJFX instead. So when we are later on going to create our graphical user interfaces, we will look at how we can import and use this instead of it being part of core Java. A little bit sad, but it also means that JavaFX and Oracle is still the major contributor to JavaFX as well, and actually development is going fairly well at the time for JavaFX as well. So we hope for the best, but more about that later on in another lecture. Lastly, Java 12 will be released in March 2019 as it looks right now. Even more optimization to garbage collection. The switch statement will become a real statement. We were supposed to have raw strings, meaning that we could just copy and paste from anywhere, having Unicode characters and so on directly into the string, but this will probably be postponed to, or it will be postponed, but it will probably be in Java 13 instead. and Java 13 will probably be released in September 2019. Probably. It's scheduled for that at least, so it will probably be there. And lastly, not all of these releases that will come so frequently now will bring large changes, but we will get changes on a 6-month basis, so new features will be added fairly fast, and those that are not done yet will be postponed to later releases, meaning that they will not uphold an entire release from being released. And on the whole, this is a good thing, I think. And by that, we are done. Any questions? No? Just closing computers? Yeah? All right then. Thank you very much for today, and see you soon again. And bye-bye, Internet. I'm not shutting down the entire Internet, just the YouTube stream, but bye-bye.